Good day. I am Dr. Alvera Viljoen from the Vaal University of Technology in South Africa. I teach chemistry to undergraduates and postgraduates. Today I am showcasing how I use the EON platform to supplement my online teaching for inorganic chemistry. At the moment, my EON lessons cannot replace my standard ways of teaching using videos, since not all my students have access to the required hardware. Under my workspace and clicking on playlists, you can find the playlists that you have constructed. So over here we can see that I've got 4 playlists. So my playlist catalysis consists of 4 lessons, and my playlist of molecular orbital formation consists of 5 lessons, and so on. So today I'm going to look at catalysis and metal complexes. So you can see my playlist catalysis consists of 4 lessons, and when we open it we can see those 4 lessons. So my playlist catalysis consists of my chemical reactor lesson, my catalyst in the pipe lesson, my catalyst particle with pore lesson, and my Haber process on the catalyst surface lesson. So the usefulness of a playlist is that it organizes the lesson in a particular order. In chemistry, one lesson usually builds up on a previous one, which means one cannot watch lessons in a random manner. I am using the playlist concept to ensure that the students go through the lessons chronologically. Now I'm going to open this lesson with a chemical reactor vessel. I'm going to choose play lesson. It takes a while for the lesson to open. So the lesson on catalysis demonstrates the usefulness of the X-ray function to see the internals of the object. For example, here, when we click on the X-ray function, we can see the internals of this reactor. One can then also use the explode function to see the different components of that chemical reactor. Now I'm going to move over to the third lesson on my playlist, the catalyst particle. It takes a while to load. So here we are looking at the outside of a catalyst particle. So I'm going to use the X-ray function that you can see what it looks like on the inside. So you can see these little pipes, they are our catalyst particle pores, and inside those pores are the active phase, those black dots. So we can also use the explode function to see the different components that this catalyst particle consists of. And we can also get the labels to show you what is the different parts of that particle. So that's on the outside of the particle, so you can use the X-ray function to see on the inside of the particle. Now I'm going to move over to my playlist with the metal complexes. Let's open that one. So it consists of 4 lessons, as you can see here on the left. So let's open one of those lessons. The lesson of the metal complexes demonstrates the usefulness of looking at an object in 3D space. The students find it difficult to visualize the geometry of certain chemical components or molecules. The geometry is a representation of how the atoms are positioned in 3D space. In textbooks or videos, the molecules may appear flat or in a 2D plane to the students, but now they can rotate and interact with a metal complex or molecule to see how the atoms are positioned in 3D space. This is a powerful learning tool which aids the students to gain insight into ligands and towards the density of the metal complex and also stereo effects in organic molecules. So let's rotate the molecule a bit. You can now see the molecule from all sides. And then one can once again use the annotation to see what the different components are. So in this lesson we are looking at the density. So we are talking about these ligands, how they are bonding. And so the students need to look at how many ligands there are and in what particular way are they bonding. So I'm going down here to see the different subsections. So we can have a closer look at this one, and you can see there are 1, 2, 3 ligands around this metal center, and we can use the explode function to see the different parts. So it's now clear to the student when they use the explode function that there are 3 ligands attached to this metal atom. Now if we look at a different one, we can see now these ligands are different to the previous example. If we explode, we can see there are only 2 ligands, and so it means each ligand are attached to that metal center with 3 places, making them a tridentate ligand. So the student can use this by rotating it and exploding it to investigate how this metal complex is constructed. So under my workspace, we click on playlists, and in those playlists we have a selection of lessons in a particular order to force the students to watch these lessons chronologically, because one lesson builds on to another lesson.